let's introduce onlinepadho.com. Onlinepadho.com has founded with the objective to reach each and every student of the country or abroad who study in CBSE board, right? So our objective is very clear. So we are trying to provide the quality education in each and every part of the country, and this is one of the ways to provide this education by video format. You can learn, you can see your class in your system, in your laptop. No need to go any coaching institution. You can avoid the transportation or congestion in traffic, right? So this is the one of very important format to introduce our classes from our video lectures. And now we are going to discuss the first chapter of class 12 mathematics today, that is relations and functions. And the first topic is relations. You know, the very important, very main problem in this country is how to reach with a good faculty, a good teacher who can teach a student in better way. So we are planning to reach that type of student who is searching for the quality education. And now we are introducing each and every chapter from class 6 to class 12 in each subjects. Now let us start with the mathematics, and this is our first tutorial in class 12, and the first topic is relations. Now let's discuss the topic relations. What do you mean by relations? You already learned in the class 11th what is a relation. A relation is a subset of a Cartesian product. If we have two sets, set A and set B, right? Let us see. We have two sets, set A and set B, and the elements of set A are 1, 2, 3, and the element of set B are 2, 4. So, what is the Cartesian product? We discussed in class 11th. The Cartesian product is 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, and 3, 4. We need to write all the elements as order pairs. 1, 2, 1, 4, 2, 2, 2, 4, 3, 2, and 3, 4. This is the Cartesian product from set A to set B. And relation is very small part of this Cartesian product. So we can say that a relation R is a subset of Cartesian product A multiply B. Relation is just a subset of A multiply B. So how many relations can be formed from these? The number of relations formed from these is 2 to the power m multiply n, where m is the number of elements in the first set and n is the number of elements in the second set. So in this case, number of relations is 3 multiplied to 6, 2 to the power 6. That is 2 to the power 6, that is 2 multiplied to 4 to the 8 to the 16, 13 to 64. You can write it as 64, right? So we can make 64 relations from this set. A relation can be written as a set 1, 2. This is the relation. You can write many number of relations. You can write a relation 1, 2. You can write another relation 1, 4. We can write another relation with two elements 1, 2 as well as 2, 2. We can write many 64 relations from this Cartesian product. And there are two forms of the relation, set builder form and roster form. These are in the roster form. We can also write this relation in the set builder form, right? So relation is very small part of a Cartesian product as we discussed in the class 11. Now we need to discuss some more types of relation in the class 12 topic, right? So now you understood the concept, the definition of relation. How can we define a relation? This is a subset of the Cartesian product, and we can find the number of relations from any Cartesian product. You can also find the relation from the set A to A multiply R, also subset of A multiply or A multiply B or B multiply C. You can find any relations like this. And in relation, you have to represent the relation in a set, and the elements must be in the form of order pairs. Because relations means we have to relate a set with another set. Relations means we have to relate a set with another set. Many types of relations, many kind of relations can possible in this. Let us see in this example, if we write that a relation R1 where X is such that, or we can write it as AB is an order pair in which A plus B is equal to 3. A plus B is equal to 3 such that A belongs to set A and B belongs to set B. This is the set builder form of a relation from this Cartesian product. So how can we write this relation in the roster form? Let us see, A plus B is equal to 3. This we have to write take the elements of from set A and set B in the order pairs that must satisfy A plus B equal to 3. So A belongs to set A and B belongs to set B, and the sum is 3. We can take 1, 2 as an order pair. So we can write an order pair 1, 2. In 1, 2, 1 plus 2 equal to 3, and 1 belongs to set A and 2 belongs to set B. No other kind of relation possible in this, no other element possible in this. Only one element possible to satisfy this equation A plus B equal to 3. So this is the kind of relation. You can write any relations with 1 element, 2 element, 3 element, 4 element and so on. You can write many relations. Let us see types of relations. Types of relations that we need to discuss in the class 12. So our first type of relation is the reflexive relation. Reflexive relation. Let us see what is reflexive relation. Reflexive, the clear from the name, reflexive means if A is an element of some set capital A, so A must be the element of that relation, right? So you can define the reflexive relation as if A belongs to set A, then A must belong to the relation. This is called the reflexive relation. In the reflexive relation, the relation is a subset of the set A multiply A only. The Cartesian product of the set A multiply A only. That is called the reflexive relation. Means, if we have, for example, if we have a set A, like the elements are 1, 2, 3, and we have a relation in which the elements are 1, 1, 1, 2, 2, 2, 3, 3. These are the elements in the relation. Is this relation reflexive? Yes. This is a reflexive relation. Why? Because the element A belongs to set A, the element 1 belongs to set A, and 1, 1 belongs to the relation. Element 2 belongs to set A, and 2, 2 belongs to the relation. 3 belongs to set A, and 3, 3 belongs to the relation. This satisfies each and every element. But if you have the relation like this from set A, this is not a reflexive relation. Why? Because 3 is an element of set A, but 3 is not the element of this relation. This is not satisfied. This is not a reflexive relation. For reflexive relation, for each and every element of set A, there must be an element in the relation. That only we can say that that relation is a reflexive relation, right? So this is not a reflexive relation for set A. But if you have 3, 3 also in this, now this is reflexive relation. No matter 1 to the extra element, no problem. But we must have 1, 1, 2, 2, 3, 3 in the relation. That relation is called reflexive. So therefore, since 1 belongs to set A and 1, 1 belongs to relation, 2 belongs to set A and 2, 2 belongs to the relation, 3 belongs to set A and 3, 3 belongs to the relation. So therefore, R is a reflexive relation. R is a reflexive relation here, right? So we can say that R is a reflexive relation. We can also take some examples from reflexive relation, right? Let us see if A is a set of, let us see a practical example. A, X is such that X is a person live in India. X is a set of person live in India. So how many elements in this set A? Population of the country. That is set A. And the relation R. Relation R. AB such that A is a friend of B. A is a friend of B, right? Or we can also say that many relations we can take. A is a father of B, right? A is a father of B. What is set A? X is a person live in India. And what is the relation AB? A is the father of B. AB is order pair. AB is the order pair. Can we write an order pair as AA? Is it possible in this? If this is possible, this is a reflexive relation. But I think this is not possible. Because the question is A is the father of B. But here A is not father of itself. A is not father of itself, so this relation is not a reflexive relation. So this relation is not a reflexive relation here. Because a person A live in India, but AA is not belong to this relation. So therefore we can say that the relation R is not a reflexive relation. This is not reflexive. Reflexive means same element must repeat in order pair. In order pair, same element must repeat. That in that case, you can say that that relation is reflexive relation. The very important thing. We will discuss the reflexive relation in detail after discussing the symmetric and transitive relation. Right? So now, our second type of relation is symmetric relation. Symmetric relation. how can we say that a relation is a symmetric relation? If AB belong to set AB belong to set A and AB belong to the relation, then BA must belong to the relation. Mathematically, this is a symmetric relation. This is according to mapping of the relation. We can say that if 1, 2 belong to the relation, then 2, 1 must belong to the relation. That we can, in that case, we can say that that is symmetric relation. For example, if we have a set A that is 1, 2, 3, 1, 2, 3, and we have a relation 1, 2, 2, 3, 2, 1, 3, 3. Is it symmetric relation? To satisfy the symmetric relation, if 1, 2 is an element of the relation, then 2, 1 must be the element of the relation. If 2, 3 is an element of this relation, then 3, 2 must belong to the relation. But in this case, 3, 2 is not the element in this relation. 2, 3 is the order pair. This lie in this relation, but 3, 2 not lie in the relation. So this relation is not a symmetric relation. But if we consider this element is as 3, 2, now we have to check each and every element for symmetricity. We have to check each and every element. We have to check 1, 2. 1, 2 belong to the relation. 2, 1 also belong to the relation. 2, 3 belong to the relation. 3, 2 also belong to the relation. 2, 1 belong to the relation. 1, 2 also belong to the relation. 3, 2 belong to the relation. 2, 3 also belong to the relation. So this relation must be symmetric relation. And each and every element of the order pair must be the part of the set. If you consider an extra element that is 4, 4, no, this is not a symmetric relation because here 4, 4 is not lie in this set. Each and every element in the order pair must lie in the set, right? So now this is a symmetric relation. Why? Because since 1, 2, 3 belong to set A, and if 1, 2 belong to the relation, then 2, 1 also belong to the relation. If 2, 3 belong to the relation, then 3, 2 also belong to the relation, right? So therefore, we can say that R is a symmetric relation. Therefore, R is a symmetric relation, right? Now we can take a practical example for this, right? Like, let us see the same example, example A. Let us see set A, X is such that X is a person live in a city, and R is the relation with the order pair AB such that A is the friend of B. A is the friend of B. Is it symmetric relation? Yes. This is symmetric relation. If we consider A is the friend of B, then B must be the friend of A. If AB belong to the relation, then BA must belong to the relation. So this is symmetric relation. If you consider PQ, if you consider, let us consider in roster form a relation. Anil and John is a friend. Then can we write John and Anil? Yeah, these are also friends. Both satisfied in this relation. You can take many elements in this, infinite elements in this. This is a relation. Now this is symmetric relation. Therefore, we can consider this as R1. Therefore, R1 is a symmetric relation. R1 is a symmetric relation. But if we consider a relation R2 that is AB such that A is the father of B, A is the father of B, A is the father of B. Is it symmetric relation? No. This is not a symmetric relation. Why? Because if AB belongs to R, then BA must not belong to R. Why? Because relation is what? First person is the father of the second person. If A is the father of B, B cannot be the father of A. If A is father of B, B cannot be the father of A. So this relation is not a symmetric relation. Because in the case of symmetric relation, if AB belongs to the relation, then BA also must belong to the relation, right? In the case of friend, this is a symmetric relation. R1 is a symmetric relation. But in the case of father, in the case of son, in the case of wife, this is not a symmetric relation. So here R2 is not a symmetric relation. R2 is not a symmetric here. R1 is symmetric, but R2 is not symmetric. We can take any example for this. We can take mathematical example also. A relation R, order pair AB, such that A plus B equal to 2, A plus B equal to 2, where A, B both belong to the natural number. Yeah, this is a symmetric relation. Right? As well as if we consider A, B both belong to the integer, that will be also the symmetric relation. Because commutative law is applicable in the addition. But if you consider A minus B is equal to some number, then that is not a symmetric relation. If you consider a relation R equal to AB the order pair such that A minus B equal to 0, A minus B equal to 0, is that symmetric? No. If A minus B equal to 0, then B minus A cannot be 0 for any number. If A minus B equal to 0, then B minus A cannot be 0. So we can say that that relation is not a symmetric relation. In the case of symmetric relation, you must remember this formula only. AB belongs to the relation and BA, then BA must belong to the same relation. This is only condition for the symmetric relation. And the very important thing is this A, B, both elements must belong to the set. Now these are reflexive and symmetric relation. Let us see our third relation, that is transitive relation. We will discuss some more examples of symmetric or reflexive relation after discussing the transitive relation. Now, third one is transitive relation. And the transitive relation is very important topic. Very important. There are two parts to satisfy this. Transitive relation. First part is if A, B, C belong to set A, right? And AB and BC belong to the relation, then AC must belong to the relation. If AB and BC belong to the relation, then AC must belong to the relation. If 1, 3 and 3, 9 belong to the relation, then 1, 9 must belong to the relation. This is called the transitive relation. And there is a second part of this relation also. If A, B, C belong to set A and A, B belong to the relation, but B, C not belong to the relation. In this case, this is also transitive. If the second element of first order pair is not the first element in any other order pair, then we can also say that this is transitive relation. So there are two types of transitivity. First type is if AB and BC belong to R, then AC must belong to R. Diagrammatically, we can say that here A, B and C. If AB belong to R and BC belong to R, then AC must belong to R. This is called transitive relation. In other case, second case, if AB belong to the relation but BC not belong to the relation. In this case, again, this is a transitive relation. So there are two different parts of the transitive relation. Now we can take some example of transitive relation. Let us see. Set A is such that 1, 2, 3 and the relation are in the order pair in 1, 1, 1, 2, 2, 3, 3, 3. Is it transitive? Is it transitive relation? We have to check each and every element. If any one element does not satisfy the transitivity, so we can say that that complete relation is not transitive. So we have to check each and every element. First one is 1, 1. We have to check the second element of the first order pair. Is it first element of any other order pair? Yes. 1, 1 and 1, 2 belong to the relation. Then 1, 2 must belong to the relation. 1, 1 and 1, 2 belong to the relation. Then 1, 2 must belong to the relation. Satisfied? 1, 2 and 2, 3 belong to the relation. Then 1, 3 must belong to the relation. This is not satisfied. Here you can say that 1, 2 and 2, 3 belong to the relation, but 1, 2 and 2, 3. Then 1, 3. Is 1, 3 belong to the relation? No. 1, 3 not belong to the relation. Here 1, 3 not an element in this. So this is not a transitive relation. So therefore R is not transitive relation. This is not transitive. In the case of transitivity, we must satisfy either this case or this case. If AB belong to the relation, BC belong to the relation, AC must belong to the relation. Then only we can say that is a transitive relation. So these are the three relations: reflexive, symmetric, and the transitive relations. And if a relation satisfies all the three relations, reflexive, symmetric, as well as transitive, that relation is called the equivalence relation. Let us see the very important point. If a relation is reflexive, symmetric, and transitive, so it will be an equivalence relation. Right? If a relation is reflexive, symmetric, as well as transitive, that satisfy all the three conditions, then this type of relation is called an equivalence relation. So these are the types of relations we discussed in this tutorial, right? First one is reflexive, second one is symmetric, and third one is transitive. We need to discuss some application based question related to reflexive, symmetric, and transitive. That we will discuss in the next tutorial. If you have any doubt regarding onlinepadho.com, you can contact us on our email ID or on the contact number. Our email ID is info@=dot-in. You know what equal sign? This one. info@=dot-in. This is our email ID. You can contact in this or our contact number +91 96509 12288. You can contact in this number, or you can also WhatsApp on this number, right? So we discussed the next part of the reflexive, symmetric, and transitive relation and some application based question in the next tutorial. Thank you.